Hi, this is Paul Gregg, and I think this is going to be my last video documenting the 2017 work I did in correlation to the MIT students' desire to build a backyard roller coaster for Rush Week. When you get to a certain point in aerospace, at least, we do some kind of more representative large-scale testing of a concept, and this is an example of what I call heavy cart testing. I filled these big containers full of water, ran it back and forth several times, put another container on, filled it with water until I finally got a very high weight, and I kept track of the deflection. The issue here at the time, I was working on a four-wheel cart, which I've since abandoned, but the issue at the time was when the wheel crosses the track tie, when it's out in between the ties, what's critical? Where is the fasteners or the wood or the PVC? What's critical? At what position the wheel relative to the track? Which one is where's the lowest failure point? And so, rather than try to test each one of those at a smaller scale, I built this so it tests all of those conditions, and you roll this back and forth and keep track of the deflection. I was able to put 830 pounds on 4 wheels, and I didn't have any failures. This is back in 2014. Anyway, I was looking for a way to help these MIT students to validate a PVC backyard roller coaster design, both the cart and the track. So you finalize your plans to make a cart and a track, and then you want to do some testing that will validate the design. So the MIT objective was to carry a 260-pound rider up to 4.5 Gs, which seems like quite a bit, but that's what they wanted to do, so the loads are going to get high. 260 pounds times our 1.5 factor safety, 390 pounds ultimate, times that by 4.5 Gs is almost 1,800 pounds, equivalent ultimate static load on an 8-wheel cart. So the way I was suggesting they do that is to build a representative track with gaps and mislocated fasteners or whatever, with some reasonable tolerance of how you could actually build this. The rail joint, the ties, everything would be tested here. Everything about the cart and everything about the track. And I called it heavy cart certification testing. So you'd put this big load on here and roll it back and forth, similar to what I did in my garage with the water buckets. You could also do fatigue. Fatigue's done at a lower load, but they thought this might be used 400 times over the weekend after they built it, and so a good fatigue test would be 2.5 times that, or 1,000 times that. When we build airplanes, 2.5 times the fatigue life is what we require the structure to endure. It's very conservative to assume all the riders will be the maximum weight. That's not really going to happen, but that's very conservative to do that. 1,770 pounds, 1,000 cycles, 10 seconds per rolling it back and forth would be about 3 hours worth of testing. When that was done, to be really conservative, you could take the fatigue tested track and cart and then do a static ultimate test. Just load it until something fails, and then you might repair that thing that failed and load it till something else fails, and you really learn a lot from one test article. Although, yeah, it's a little risky business. So this is actually the way Boeing, when they started out in the early 1900s, they would turn an airplane upside down and put sandbags on the wings until they broke off. And so this is an effective and simple way of doing it. You want to put jacks under these barrels that you're putting sand or water in so that you can load it all at one time and then unload it if you want to check things out. So this is what I was suggesting that they do to certify a design or validate a design. So the other presentation I was going to include is this one. I had another idea that you could do if, in other words, I've done a lot of element level testing and have some experience in my backyard with 3 backyard roller coasters. But if you were going to go to the next level and really validate PVC backyard roller coasters, you might look at something like this, which I call the BigU design validation testing. And I didn't build this. I don't think I'm inclined to build it, but if somebody wants to do this, this would be the next step in the research and development of PVC backyard roller coasters. Start off with objective of the test, do fatigue and dynamic loading. This would be, for fatigue, you'd probably be more realistic and do 66% of limit load. So 200. This is still with the MIT students. So 260. 2/3 of that is 173 pounds, and have some kind of a pulley system so that you could repeat this test running this cart back and forth 1,000 times or whatever you wanted to, 2.5 times its design life. Then you could put more weight on it and run it back and forth, not 1,000 times, but a couple of times to see what its real ultimate capability is. And you could vary a lot of things here. The nice thing about this is you'd build it representative, and this side of the track would have equal structure over here. You could have different kind of fastener concepts, track to tie fastener concepts, which I've gone through in the last video. I had lots of them. You could put different ones in here. You could mislocate fasteners. You could put Schedule 80 in, and then put Schedule 40 in. You could do this test a lot of different times. When something fails, you've learned something, you document it, and then you repair that and continue testing. The details that would be validated would be the PVC rails themselves, holes in the PVC rail tie joints, main wheels, main bearings, ties and framing, and the whole cart design. So you're validating the track and the cart designs with this kind of testing. I did fracture toughness testing before just by impacting a pipe laying on my cement floor of my garage. This would be much better than that, because if you mislocated a fastener head, the wheel would hit it every time this cart goes by, and you get a real idea whether the PVC next to the fastener that was being hit would really fracture. And you could do this after 2 years of exposure or something, and really find out more accurately if this is a valid design. You could do it with painted and unpainted PVC exposed to UV, just like I did in the fracture toughness, but you get the idea. That was interesting, you know. I talked about 4.5 Gs, and I suppose somebody could build this and ride it themselves. Understand, you're going to see 4.5 Gs in here. That's equivalent to the highest acceleration roller coaster on the planet, the one in South Africa. And your head actually sees higher Gs because it's going through a smaller radius path. And so your head's going to see 5 Gs or more if you're doing this. And not for very long. Like, I think I did the analysis on this, and the duration of this was only 0.7 seconds from the time you drop the cart to the time it's in the curvature there. So it's probably only 0.2, 0.3 of a second in there. And there's a whole other discussion about accelerations and duration of those accelerations. But you might be surprised to know that just in your backyard with a 15-foot high track and a radius of 2.6 meters, by this equation, your centripetal acceleration is 3.5 G's. You add that to 1 G of gravity and you're at 4.5 G's. So you could have a really heavy-duty experience with a pretty rickety, small backyard roller coaster. Maximum speed I saw here was about 20 miles an hour. By this equation, velocity is more important, but you can increase the centripetal accelerations by reducing the radius, which is what I did, and got 4.5 G's. Nearly 1,000 pounds of force every time it rolls. So, and then I suggested using one of my later designs, the 33rd design for a steel cart. This is a very low profile, low center of mass cart. You need to adapt that to put a weight on it somehow, or a rider if you really want to, and ride that thing. So that's the end of what I'm going to document. I have even more analysis and development work that it would be very tedious to go through, and if somebody wants to have access to that information, contact me and I can give you access, and you can carry on the work of development and research of backyard roller coasters. I think that's it. This is kind of like I said, if I was going to continue, this is the kind of thing I would do. And that's it. Thanks for listening. Bye.